Good morning. I'm Peter Dyke, Executive Director of the Alliance for PE Pipe. We're here today for another edition of the PE Alliance's Education Series. Today's focus is the features and benefits of PE pipe for municipal, sewer, and water markets. So I'm often asked, well, who is the PE Alliance? Well, the Alliance is a trade association devoted to sharing everything that we've learned about polyethylene pipe to municipal leaders, to consulting engineers, and to the contracting community. Our mission is to conduct educational events, seminars, attend trade shows, wherever we can go and find people who are willing to learn more about a revolutionary product that will solve a lot of problems for municipal leaders. They will drastically alter capital programs in many cases. We've seen it. We have the case studies. So we have some exciting material to share. So today will be a short snippet of some of what we've learned. So the Alliance uses these educational training events to engage leaders of municipalities. We conduct these events, we call them road shows. Smaller versions are called seminars. Oftentimes we see after we do a road show, we'll do 3 or 4 seminars in that same city, which are smaller events, more intimate, if you will, 15 to 20 people instead of 50 to 60, where we actually show fusion, we show fittings and equipment, and we explain not only the features and benefits of the pipe, but how it's used in the field and how it's installed, importantly. So the leaders of the Alliance for PE Pipe are the resin producers like Chevron Phillips, Dow Chemical, Equistar. They are the pipe manufacturers that take that resin and turn it into pipe, like Performance Pipe, Duraline, WL Plastics, and Pipeline Plastics. They are also fittings manufacturers and equipment manufacturers like Strongbridge Tega and McElroy Manufacturing. So these organizations fund the operations. We go around the United States and conduct these events. We also have 50 other organizations that are members of our alliance that attend our events and sponsor them throughout the United States and Canada. So what you find at the end of the day is that the Alliance for PE Pipe is an organization that has all of the major members of the polyethylene pipe, fittings, and equipment community throughout the U.S. and Canada. It's an important force that is shaping the market, and it is capturing percentages of the market that are available. So we're excited to be here. We're excited that you're listening, and we're excited to talk about polyethylene pipe. So what is it we do? We've got these education sessions that we've talked about. We also do program reviews. So if you're an engineer and you're thinking about doing a pilot project with polyethylene, or you're trying to use it in a manner in which you've not used it before, we'll talk through that program with you. Say, hey, yeah, this is a good project for you to get into polyethylene with. Oftentimes we find that pipe bursting is the gateway method, if you will, that municipalities use polyethylene for the first time. They use it because they have to. Change is tough for municipalities, for good reason. But this product now has plenty of precedent, plenty of history behind it, so that you should feel confident that you can use polyethylene pipe. Oftentimes I'll hear, hey, I don't think contractors know how to use this product. It is a little different to install, but it also lasts over 100 years. So we can put together these qualified contractor lists so that the leaders of the organizations know that there are people that can actually do a 30-inch transmission line in your boundaries. Spec edits. Specs are critical to the proper installation of polyethylene pipe. Send me your spec, I'll do a track changes, send it back to you, take what you want, but at least you'll know what we think should be in your spec. Oftentimes we'll get a PVC or a ductile iron spec, we'll spend a few minutes on it, convert it, and it'll be good to go for polyethylene. And importantly, the Alliance for PE Pipe has access to the best and brightest in polyethylene in the United States and Canada. As I said, over 60 members. We know most everyone in the industry. And if I don't know the answer to your issue, I will find somebody that does in short order. So where can you find us? On the web, we're at pepipe.org. Sign up for the next roadshow coming to your community right there. A technical resource for us in the industry is plasticpipe.org, also known as the Plastic Pipe Institute. And you can go to our many member websites and find technical data there. Now the standards for polyethylene pipe are well established. You can be rest assured that AWWA, ASTM, the CSA, and the NSF are all paying attention to polyethylene pipe. and our products are manufactured to the specifications of those organizations. I mentioned PPI before, the Plastic Pipe Institute. They published a tremendous book, a handbook, if you will, on polyethylene. Many of the questions that I get, that I respond to, I get the answers out of that book. Now, I wouldn't exactly say it's bedtime reading, but it really is a great resource. And oftentimes when I respond to a question, I'll include a chapter from that book, a single PDF chapter, going to the questioner for backup on our response. I'll also say you can get that book at PPI's website, plasticpipe.org. It's about $50 sent to you. Or if you send me an inquiry, I will send you it's about a 15 meg PDF of the entire book, free of charge. So the question, why use poly? Why should I even consider it? We're pretty happy doing what we're doing. Yeah, we've got a few breaks, but why should I even consider polyethylene? Well, here are 5 really good reasons to consider using polyethylene. It doesn't leak. It doesn't corrode. It doesn't care about caustic soil. You don't really have to maintain it. And, oh, by the way, it's pretty tough, ductile, and flexible. But I'm going to talk about the superior seismic resistance of polyethylene pipe. Why seismic? Why I don't have earthquakes? Well, I'll tell you, if our pipe can handle seismic issues, significant ground ruptures, it can handle whatever you can throw at it in your municipality. It can handle the freeze-thaw. It can handle soil constriction. It can handle construction methods and techniques that impact underground pipelines. If it can handle earthquakes, it can handle anything your municipality can throw at it. And now I'm going to prove that to you. So, the Water Research Foundation. Many of you perhaps are members of the WRF, if you will, located in Denver. Have about a $6 million a year budget devoted to research of all things pipelines, not just poly. Poly is a very small part of what they do. But they did a study that was specifically done by a guy named John Ettinger and Craig Davis in California. Ettinger and Davis sent crews to the 3 largest earthquake events that occurred in the world in 2010 and 2011. And they sent them multiple times. This is available on the web at WRF's website, waterrf.org. It's their report number 4408. You can Google that number and get it, or I can send it to you. We had nothing to do with the report. We didn't fund it, nor did we participate in the research. So Ettinger and Davis sent crews to Christchurch, New Zealand, Concepcion, Chile, as well as Sendai, Japan, on multiple occasions, and learned a lot of things. There were several common denominators of all 3 of these earthquakes, other than they killed a lot of people. There was a lot of monetary damage, significant impacts to economies as a result of these earthquakes. Christchurch, New Zealand's case, there's a $30 billion hit to their economy. Concepcion, Chile, up to $7 billion. And then, of course, in Japan, which most of us are familiar with, it was up to $1 trillion in damage in that country alone. In the case of Christchurch, 185 people died, 525 died in Chile, and over 15,000 died in Japan. The number of breaks on the screen is significant in each of those 3 locations, on the water and the sewer side. And even with these thousands of deaths and billions in damage and the severe pipe damage throughout all these locations, guess what? No reported polyethylene failures in water, sewer, or gas. That's in the report. No failures of polyethylene. If polyethylene can handle the earthquakes, the 3 biggest earthquakes in 2010 and 2011, it can handle whatever's going to go on underground in your community. You should give polyethylene a try. So specifically, the Tohoku quake in Japan, what happened there? Well, it was a 9.0 earthquake with an ensuing tsunami. The shaking lasted up to 5 minutes in some locations. And most of the failures were caused by pulled joints. The phrase that struck me when I read this report was seismically resistant. Ettinger and Davis said polyethylene pipe is a seismically resistant pipe. They recommended people seriously consider polyethylene pipe as a result. We all know how much time and energy that we spend fixing broken bell and spigot systems. Why? When there's something better that's available. In the case of Concepcion, the thing that I find fascinating here is we have SBO, a private for-profit water company that came in prior to an earthquake in 2001 and started making all the fixes with polyethylene. All those fixes that they made in that 2001 quake survived beautifully in the 2010 quake. No reported failures. So now we have SBO, a private for-profit water company, saying, hey, not only did polyethylene survive in 2010, all those pipes, the 10 years worth of pipes that we put in as part of our capital program also survived. That's exciting. And that's proof. That's objective data that says polyethylene pipe can handle seismic issues well, without failure. Without failure. So in Christchurch, 4 6.0 earthquakes and greater over a 15-month period in one municipality. 4 of them. The one in Napa in August of 2014 was a 6.0. Imagine that 4 times over 15 months. So they had over 1,700 line breaks. After the first earthquake, the mayor of New Zealand called up Tom O'Rourke, Dr. Tom O'Rourke at Cornell, and said, hey, we had a bunch of breaks, what should we do? O'Rourke said, have you considered polyethylene? And the mayor said, nah, we use it for gas, but we don't use it for sewer and water. A familiar refrain in the United States, to be sure. So O'Rourke said, please consider it for water. Take a 1.5 mile section, fix it with polyethylene and see how you like it. Try it in the water side. So the mayor did. Little did the mayor know, earthquakes 2, 3, and 4 were going to come along, and that 1.5 mile test section did just fine. No breaks, no damage to it or the gas that was already in the ground. So the mayor of Christchurch, New Zealand was sold on polyethylene pipe. All the fixes after 2, 3, and 4 were done with PE pipe. So, seismically resistant is now in the lexicon of the engineering community in the United States. Or if I have anything to say about it, it will be. But it's an important phrase. And if we can take a 500-foot section of 6-inch polyethylene pipe and roll it up like that image that you see in the screen, it can handle an earthquake event. It can handle what you can throw at it in your municipality. So freeze thaw, no problem. Don't worry about breaks in the middle of the night. Let's take a look at Thomas O'Rourke at Cornell. Why did the mayor of New Zealand call him after that big event in 2010? Well, O'Rourke had done a study in 2008, which he called his buried pipeline study, that basically was a ground rupture study of the effects on underground pipelines of a simulated earthquake event. You can find his information on his website at the university. So what he did is he took a 50-foot trench box, filled it full of dirt, and put a 35-foot stick of polyethylene pipe in there. Now that was a 16-inch diameter DR11 pipe. This video is the top view of what occurred with O'Rourke's study. That 4-foot shift, that lateral shift of the polyethylene pipe. Not only did he take a video of the top-down view, he also stuck a camera in the middle of that pipe so we can see what happens. Let's take a look. That's what it looks like inside a 16-inch DR11, so pretty thick wall, stick of polyethylene pipe. Pretty impressive. So as O'Rourke says, the experimental evidence confirms HDPE pipelines accommodate severe deformation associated with earthquake-induced ground rupture. That's right out of the Cornell report. So that means the 2 male ends of polyethylene pipe fused together can handle significant ground deformation. That means fused PE pipe can handle freeze-thaw in Grand Rapids, in Chicago, soil constriction in Houston, and earthquake events in Seattle, Los Angeles, and Napa, California. So why not use a pipe that doesn't break? So the cost of water, it's very expensive. You do a lot to deliver water to your customers. Why should it leak? Polyethylene doesn't leak. We respect the value of water with polyethylene. We think you should too. So today, I have the pleasure of introducing Richard Kolassa. Richard is the technical director of WL Plastics. He's an expert in all things poly. So he will share with us the features and benefits of polyethylene pipe.
Today, I'm here to talk about high-density polyethylene and the features and benefits and how it can work in your municipal water and sewer markets. Today, I'll be talking about the corrosion resistance of polyethylene pipe, the advantages of being a leak-free system, the benefits of reduced maintenance costs for today and future generations, service life of the product itself, and understanding how it can benefit your current municipality and water systems. I'm also going to talk about the flexibility and how tough this product really is. The reality is of the polyethylene pipe, we have a product that we believe will help eliminate a lot of the issues of an aging infrastructure that is currently a big problem in not only North America, but in all parts of the world. I'll also talk about the pressure rating of a product so you understand how these products can operate and how you can design them specifically for your applications in water and sewer. Polyethylene pipe does have a limitation of pressure rating. It's not like a steel pipe because it is a thermoplastic material. It can be used up to 320 psi of operating pressure, which gives you lots of flexibility in municipal waters which typically don't operate in those types of pressures. I'll also talk about the leak-free system that polyethylene offers in your water and sewer applications. A zero-leak system means that the water that you're pumping into the pipeline after treating the system to very strict regulations and conditions is not going to be affected by infiltration or exfiltration. The corrosion-free aspects of polyethylene means a long service life. It does not corrode and it does not tuberculate. So the aspects of that means your system is going to operate as it would the first day that you designed it and started it. It's a self-restraint product that when you fuse the product together, it actually benefits and holds together, and you don't have to worry about restraining the product in the ground. It will do that on its own. In this particular picture, it shows that there are an aspect of a washout which actually held together. So your service lines are still providing, whether they're fire main or water supply, into those areas. But that self-restraint system and leak-free and corrosion resistance really does mean for extended life. It is very impact resistant. We have equipment that can damage pipe and by third party, which is typically the failure mechanism for polyethylene pipe, which doesn't happen very often. But this impact resistance means it's very tough. It is also a very flexible product. Although polyethylene pipe seems a stiff product, it is ductile. And this flexibility helps you not only in installation, but gives you versatility in how you can stage and prepare to install polyethylene in your municipalities, especially in urban areas. As you can see in this video, polyethylene is very flexible. Apparently this gentleman didn't get the memo that we were installing pipelines today, so we had to lift the pipe so he could drive his car to attend to his daily business. The flexibility also is very well understood in the polyethylene industry. We understand that for various products we have minimum bend radiuses that we need to follow and understand. In some cases, the installations will not require fittings that need to change the direction of the pipe. In this case, you can see in the picture it's actually bending and following the contours of the land, which actually helps reduce the installation times and gives you flexibility, with no pun intended, to actually install quicker and more efficiently. In this particular case, the flexibility also applies to your maintenance and installations. Okay, this squeeze-off tool, because of the ductility of polyethylene, allows you to cut off the water sources to make sure that you can utilize fusibility of the product. That fusibility, maintaining a leak-free system, will also add to a monolithic system, which again adds to that leak-free confidence. In this picture, it also depicts the squeeze-off of polyethylene. Again, this is a controlled procedure that is used in maintenance or in tapping into systems to allow for a contamination-free fusion of that system. Again, creating a leak-free environment for that pipe. The pipe is flexible enough that it can be squeezed down to cut off the water source so you're able to fuse to maintain that monolithic system, but it'll also go back to its original shape as long as yield points are not exceeded. And these procedures have been studied and tested to ensure your system maintains leak-free and it maintains the ability of the product to perform as expected. Polyethylene has a lot of resistance to chemicals. Everybody in their garages or in their homes have these containers which contain hydrocarbons, various chemicals, and it resists the ability to permeate through. This chemical resistance is understood with polyethylene. And the reason we understand it is because if you're using it for a system other than water or hydrocarbons in the case of the oil and gas gathering systems, then we're able to utilize it to make sure that we understand that these chemicals will not permeate and damage your piping system. So we have a lot of flexibility and we have a lot of documentation and understanding what the polyethylene capabilities are. Another feature of high-density polyethylene pipe is understanding the flow rate of polyethylene, especially water systems and sewer systems, and how that's designed into your flow characteristics and needs for that product and that pipeline system. The Hazen-Williams factor is a factor that is used for all different types of piping systems. For polyethylene, the value is 150. And this is really a benefit because it's one of the highest flow factors of all piping systems in the industry. And this accounts for how you properly design and ensure that you're providing the proper water flow to the communities that you're servicing. Polyethylene is designed based on IPS, iron pipe size, or ductile iron sizes, which is DIPS. And these are controlled specifications that we produce and manufacture our product to. The IPS allows us to be consistent and standardized with existing piping systems. And these piping systems then can be matched or linked up to existing piping systems which we have in the ground today. And this is an advantage because we don't have to reinvent the wheel to try and customize fittings to match up to these existing piping systems in the ground that still have the integrity to last in future years. The ductile iron pipe size is the same effect, and those specifications are specific to that design and manufacturing of that product. And what that really means is it does match up, and it has the ability to be compatible with those existing systems. Polyethylene can be identified in many different ways. First of all, print lines will identify what that product is for. However, as a quick reference on the beginning of an excavation, striping can be put on the pipe to identify water lines, gas lines, which is typically your yellow color, and your reclaim lines, which could be green or purple in some cases. There's also FM, which is factory mutual for fire prevention systems, that is identified by red. Another feature and benefit of polyethylene pipe is it can be colored to many different types of colors. However, these colors are controlled in terms of the formulation, but to meet the needs, for example, for video inspection, we can lighten the color, whether it's the inside surface or the total pipe wall, to ensure that we have good, accurate video inspection of your pipeline system or your existing pipeline or installed pipeline system. Polyethylene pipe is designed by dimension ratio. Dimension ratio is a formula that is the outside diameter of the pipe divided by the thickness of the product. What does this mean? Well, for polyethylene pipe, we have various dimension ratios for varying pressure needs. These pressure needs are really important in the design of your pipeline system. If your operating system is based on 100 psi for the lifetime of that system, then you want to design that pipeline system based on the proper DR. Why is that a feature and benefit? The fact is, we sell polyethylene pipe by the pound. We also purchase the polyethylene raw materials by the pound. And this will add cost benefit to you if you use and utilize the proper design factor. If you put in a heavier wall pipe for a lesser designed system, you're over-engineering that system. And that over-engineering will only cost you money. So we encourage to understand the DR because it will help you properly design. So with the understanding of dimension ratio for polyethylene pipe, we also have to understand how did that become where it is today. Well, what's changed is the resin itself, the materials and the products that we use to produce polyethylene pipe. We've moved from a PE 3408 material, which is a cell classification of the older generations of resins, to now PE 4710. So what does that mean to us? And what does that mean to you? Well, for us, that means we can produce a thinner wall pipe and maintain the same type of pressure, which actually is a reduced cost benefit to you as the user of that polyethylene pipe system. In this particular slide, you can see the DRs and the comparisons between the pressures, which gives you that advantage. PE 3408 materials are no longer available for us to produce into polyethylene pipe, so you set your specifications and your designs around the PE 4710s. Other features and benefits of polyethylene pipe are really the corrosion and the tuberculation of those products. Polyethylene pipe does not support any biological growth for the lifetime of that pipe. As you can see in this slide, steel pipe will corrode, it will build up biological aspects which causes problems within your piping system. Tuberculation narrows the ID of that flow channel which the pipe is going to, plus you're taking a very well treated water and pumping it into this dirty system. Polyethylene resists that type of growth, and the flow velocities and flowability of the water inside that pipeline system will not change. This is very advantageous for the longevity of the product. If we end up corroding and plugging up the systems, it's going to affect how your maintenance and how your pumping systems will work. As you can see in this slide, we exhumed pipe that was over 41 years old. And that 41-year-old system was as good as the day we put it in. We put it through all the rigors of testing, and it actually fell into the same cell classification as the day we put it in. This tells you that you have an advantage. It can't be impeded by roots. It can't be jeopardized by ground movement. So your system is intact. In addition to not corroding, not affecting the flow velocities of the product inside the pipe, high-density polyethylene has a track record of being the lowest failure type product in the market. There's a UK study done that shows that polyethylene was literally had the lowest failure rate of all products in water and sewer applications. A close-up look at this shows that the various products such as ductile iron and PVC have higher failure rates than polyethylene. This is a benefit to you because you don't have to spend time maintaining and spending money on constant repairs. Another feature and benefit that we need to understand, as I mentioned before, is the resin evolution of polyethylene has definitely improved. This works to our advantage, that we have higher pressures, stronger products, but it really understanding these changes means that you have to make changes as well to your specifications. Because if you don't keep up with the current products, then the accuracy of your specification may be in jeopardy. Another feature and benefit of polyethylene pipe is its ability to absorb the energy of surge events. And this is really important to understand because these types of events can be catastrophic to other pipeline systems. It is defined by reoccurring and occasional surge. What does that mean? On an occasional system, meaning that an uncontrolled event such as a power outage turns a pump off and on. And the reality is that that water hammer is uncontrolled. So you don't know when that event is going to occur. So you have the ability, polyethylene has the ability to resist 2 times the MOP or the maximum operating pressure for millions of cycles over the lifetime of that pipe. On a reoccurring system where you're actually turning the pumps off and on a controlled basis, we reduce it a little bit, however, still has significant 1.5 times the MOP to resist these surge events. And this is important to understand because it gives you confidence in the reality that the high-density polyethylene pipeline system will work through those uncontrollable or controllable events. The other features and benefits of polyethylene pipe are not only related to the material changes in design and the reduction of cost because of the added toughness of the products, we also have installation advantages and features and benefits. And this is really important to understand because this will help save cost and time of installations, especially when we're addressing a failing infrastructure across the continent. Direct bury is one of the ways that we use to install pipeline systems. We're all aware of that. But the advantages of polyethylene pipe is we don't have to dig big, huge trenches to have people in the trenches to install and put together a bell and spigot system. You can actually build the system outside the trench and have it ready to go into the system, which saves you time. And also, it takes less energy to dig out the earth and move the earth to put that line in. But there's one aspect of polyethylene pipe, especially when we put it in the ground, is it's hard to detect. So we have to be able to trace that product and where it is at the time of installation. Because it's a thermoplastic product, it doesn't send back a signal from ultrasound when we go to look for these lines. The reality is that we have to put tracer wires, some type of identifier that this pipeline exists there. Not only does that help us understand where it is, but if something happens on a crossing utility, we can make sure that we don't go in and cause third-party damage because we didn't have the identifier on that pipe or didn't locate it where it was supposed to be. Another system of installing through this video is called pipe bursting. And what you're seeing here is an open excavation, which is typically underground. The reality is that we can take an existing pipeline, let's say a corroded pipeline, and without digging up the infrastructure, we can actually replace the polyethylene line. What's the feature and benefit of polyethylene? Well, the reality is it's flexible, and it allows us to bend through two little entrance and exit pits that we can actually follow that head that crushes or bursts out that existing pipeline system. This is a huge advantage in terms of cost, because you're not digging up our roadways, because that's where we typically put our pipeline systems, and also you don't have to redesign right-of-ways, so that also saves additional time. Plus you're getting a brand new line that's associated with that operating system. Another technique that you can use with polyethylene pipe is slip lining. This is when the integrity of the existing line is still in existence. It has the integrity, but you want to just extend the lifetime of that system. And so what is called is slip lining. So the slip lining typically doesn't account for the pressure rating, because you're still relying on that host pipe as to hold those pressures and aspects of the operating system. Some of the advantages of trenching. This particular line is a 10-inch line where you actually drill in the same time that you're moving the pipeline. So this pipeline was fused together in a 3.5-mile section. And in that 3.5-mile section, they installed it in less than a day and a half, which is really unheard of in terms of efficiency. Please ensure with this type of system that you know where all your crossing right-of-ways are, or otherwise you're going to end up with a bad situation. You can also use polyethylene for above ground applications. Temporary systems, we have flood events that occur. This particular picture showed there was a Little League tournament that was happening in the US, and it was flooded by the river that was adjacent to the ball diamonds. So they literally installed an above ground system to pump that water out so they could continue with that event, which is significant to the economy and the benefits of that town. And plus the Little Leaguers got to play baseball. You can have temporary systems to move water, which is very, very good. And the benefit and feature is that high-density polyethylene is not affected by UV degradation. And that UV degradation does not impact the ability for it to hold pressure. There are several other above ground water installations. For example, the mining industry utilizes polyethylene pipe above ground, so it literally can move that pipe around and be flexible to the changing areas that they're excavating. Bridge crossings is another way to use an above ground application. However, you have to understand how that bridge location is going to affect expansion and contraction of that product. Another technique that's used to install polyethylene pipe is directional drilling. Directional drilling is becoming very, very popular because not only does it protect conservation areas, but it also is very efficient in terms of time in installing very large line. In this particular picture, this is a 24-inch line that went under a roadway and under a river at the same time, which really gives a huge advantage to time and installation of moving that service forward. So why polyethylene pipe? There are so many features and benefits, not only in the changes that have occurred with the new materials, but you have a very low failure rate. You're very flexible in how you can install, and very flexible in terms of how it operates and works. You also have no corrosion. You have no infiltration of roots or anything into that system. You also have no leakage. So then the water quality that you're taking out of your system is the same water quality delivered to those customers. You also have the fuse joints, which again enhances the leak-free system and makes it a monolithic system.
In a typical potable water system, what's the impact of chlorine on high-density polyethylene pipe?
Well, chlorine is a very aggressive oxidizer, and it affects not only polyethylene, it affects ductile iron, PVC, and all the different piping systems that we have in the system today. So what it does is it actually causes an event called slow crack growth, and that slow crack growth is actually a crack initiation. So it makes basically the polyethylene more brittle. So it moves it from a ductile state to a brittle state, which causes the failure to occur. So with the new generations of polyethylene, the PE4710s, for example, we've improved the slow crack growth resistance of this product. So for example, a PE3408, which is nothing wrong with an existing system today, had a PENT value or an ESCR value, which is environmental stress cracking value, to resist or determine what that slow crack growth factor is. And 3408s, those numbers were typically 10 hours, 10 to 20 hours of resistance of pent. So in that pent test, which is called the Pennsylvania Notch test developed by Dr. Norman Brown, they actually determined and correlated a lifetime of 1 hour of pent was equal to 14 years of service life. So when you put the 3408s in that situation in 10 hours, then you had somewhere between 30 and 50 years of service in that product. So when you're exposed to chlorine, then it actually accelerates that ability for slow crack growth. Well, the Today materials of the PE 4710s resist much, much greater. The example that I use, or the analogy that I use, is a PE 3408 is like a kid's ball pit. That when your kids jump into the ball pit, they can move around in that ball pit. Well, that airspace between the molecules of the polyethylene is how that chlorine or that oxidative agent reduces the performance of polyethylene, making it brittle. The 4710s today now, what they've done in the design of the polymer is literally added Velcro to every one of those balls. So when you have the Velcro system in place, they're actually tied together, and that's referred to as tied molecules. So now your slow crack growth event cannot happen. So new 4710s are exceeding 10,000 hours of pent. So now your service lives from 10 to 20 hours to 10,000 hours are significantly different.
And as a follow-up to that, then, are there any compatibility issues with the newer resins versus resins that have been in the ground and in systems over the last 10 to 15 years?
Thank you. That's a really great question, because we're involved with lots of different products. We have our ductile irons, our PVCs, our concretes, and everything. So we have to have compatibility. So first of all, in design of the polyethylene pipe, all the design of the polyethylene pipe for IPS and ductile iron pipe sizes are to those specifications. But they're also compatible. We've developed fittings and transitions to make sure we are compatible for long-term service of polyethylene. So yes, to answer your question, polyethylene is compatible. And the other aspect of that is the 3408s versus the 4710s, we are also compatible with. So your fusibility system doesn't change. The processes and procedures to put a 4710 and a 3608 product together are very, very compatible.